So here I'm picking up on problem 11. I did in the previous video parts A and B, so I'm going to do parts C and D here. And so we're doing an Argand diagram, UVW, and those are the roots from before. And an Argand diagram is just where you plot them like XY points. And so I'll copy down what my UV and W were from the previous problem. So U, where are you? U is equal to 12 to the sixth power e to the I times 5 pi over 18. V is 12 to the 1/6 e to the I 17 pi over 18. And then W is 12 to the 1/6 e to the I, and is it 29? I believe it's 29 pi over 18. But you can also, because they wanted the angles in between negative pi and pi, make that equivalently negative 7 pi over 18. So I'm going to go ahead and make that switch just so it matches up with the previous answers. So that'll be a negative 7 pi over 18. And so the nice thing about this polar format is, so let's draw our imaginary axis and our real axis. They all exist on a circle, and the radius of the circle is 12 to the 1/6 power. So 12 to the 1/6 power, let's just calculate that real quick. 12 raised to the 1/6, about 1.5. So just to help you visualize, about 1.5. And then we can just use the angle to mark where we are. And so let's see, 5 out of 18. If I wanted to do 5 pi out of 18, it's a little bit under a third. So kind of like 60 degrees. So I'm just going to mark this is approximately where U is, because this angle up to this point right here is approximately 5 pi over 18. Then 17 pi over 18 is almost a half circle like that. So that would be V. And then negative 7 pi over 18 is down here. Something like that. So this will be W. So I will now, in a different color, draw the triangle UVW. So let's just do black to connect them. And what you should be noticing is, because these are 3 points on the circle here, they're all the same distance from the center. This is an equilateral triangle here. And if you look back on your formula sheet, you can see that the area of a triangle, well, one formula for the area of a triangle is 1/2 AB sine of C. And so what we're going to need to do here is calculate what the angle is. Well, that's 60 degrees. And then calculate the side lengths. And let's see here. What's the quickest way to do that? I'm going to pause for a second. Okay, I am not certain that this is the quickest route to get there, but this is what comes to mind, is that when you have something in this RE to the I theta format, RE to the I theta is equivalent to R times cosine theta plus I sine theta. And so we can use our calculator with these values here to get the coordinates and then use the distance formula. So I'm going to grab a calculator and we'll try to do it that way. All right, so if we're trying to find the coordinates, we really only need two of the coordinates because it's equilateral. So let's just do u and v. So let's do the u here. What I'm going to do is have 12 to the 1/6, and then I'm going to find the cosine of 5 pi over 18. Cosine 5 pi over 18. I'm in the correct mode. So we get about 0.64 plus I times the sine of 5 pi over 18, which is 0.766. Okay, so if we multiply those coordinates out by 12 to the 1/6, so let's go 12 raised to the 1/6 times the cosine of 5 pi over 18. So we get our u coordinates are, let's try to squeeze this in, 0.97, 0.97, and the y coordinate you can find just by switching cosine to sine, 1.159. So I'll write 1.16 like that. The v coordinates are found almost the exact same way. All you need to do is change 5 pi over 18 to 17 pi. Let's do this correctly. There we go. So I have my v coordinates. I have 0.26 is the y value. And switching sine to cosine gives me negative 1.49. Okay. All right, so then now that we have our two coordinates, the distance between u and v, the distance between u and v is like Pythagorean Theorem. So I'm going to go 0.97 minus negative 1.49. So that's going to be 2.46 squared. That's the x coordinates. And then we had 1.16 minus 0.26. So that's the y coordinates, 0.9 squared. So square that plus 2.46 squared. So our distance is the square root of 6.8616. So I'll take the square root. So the distance is 2.62. So the area of that triangle is then 1/2 times a times b. So that's the same 2.62 squared. And then the sine of c, it's a 60-degree angle because it's an equilateral triangle. And so the sine of 60 is 1/2. So times 1/2. And so we'll square that, divided by 4. Looks like we get 1.72. I'm going to keep thinking about that one because I have this suspicion that there's a slightly more elegant way to get there rather than just kind of brute force like I used there. Okay, so what I'm going to do for the last part is the sum of the roots. And so I'm going to keep up my Argand diagram, and I'm going to erase most of the other stuff. So just give me a second here. Because when you add your complex numbers, you can think about it visually. And so give me a second. And let's see if we can find something nice about adding those up. Okay, almost there. Okay, so that looks good enough. So when you add two complex numbers, you're adding the real parts together and you're adding the imaginary parts together. And so you can think of it graphically like you are creating a parallelogram. And so if I wanted to consider the sum of the roots u, v, and w, one way to do that, here, let's actually erase that triangle. And then we'll try to add together u, v, and w. So if I add, doesn't matter what order you go in, let's just add u and v together. What I would do is take this and tack it onto the end of v and add it together. And so then what you can see is this new vector here is u plus v. And then if we want to do the same thing, what you might notice is that I can't make a parallelogram out of u plus v and w together because they actually form a straight line. And so if I add them together and they're pointing in opposite directions, then you can see that the sum of them is going to come to the origin. And so because the sum is the origin, you know that if you added up u plus v plus w over here, the sum of that would equal 0. Now the question actually asks us about cosine, which is a little bit tricky, and you need to think back to the idea that I discussed a minute ago that r e to the I theta is actually r times cosine theta plus I sine theta. So what we know is that all of this adds up to equal 0. And the only way that it'll all equal 0 is if the cosine value is equal to 0. The cosine values add together to equal 0, and so do the sine values. And there's one small detail here, which is that the question D has a positive 7 pi over 8, but our W has a negative 7 pi over 8. And that is okay because cosine of negative theta is actually equal to cosine of theta. Cosine is an even function, so it works the same on the positive and on the negative side. And so we did show then, we showed with our graph that the three roots sum to equal 0. You could also have done this with the brute force technique where I was finding the coordinates by typing it into my calculator and going from there. So it's a little bit of an uglier problem. I'm going to keep thinking about if there is a more elegant way to do part C and maybe a more elegant way to do part D. But that's good for now. Feel free to ask for follow-up if you want.